All right, simplifying radicals day 3, which is 10.2 day 3. Let's just review. Sorry, I forgot to erase that. So when we multiply radicals together, we do number times number. This time I just have that 1/3. I'm going to leave that 6, but I'm going to break that 24 up into 6 times 4. So I could have broken the 6 up right away, but I have a pair of 6s here. So if I have 2 together, I know 1 can come out. So times 6. And then I have the square root of 4. But I know that square root of 4 is actually square root of 2 times square root of 2, or square root of 2 times 2. So I have 2 together again. 1 can come out. So I have 1/3 times 6 times 2. Which is 1/3 of 6 is 2 times 2, which is 4. So the answer here is 4. So division property of square roots. Remember we said we can't have any radicals in the denominator, so I'm going to rewrite this as a times the square root of b to simplify. I can't leave the square root of b in the denominator, but I can break that one radical up into 2 separate radicals. So division property, remember I could break it up, so I have square root of 36 over square root of 49. And remember I told you I always check to see if the numbers are perfect squares. If you don't know, by using your calculator, square root 36, enter, and see if it's a nice perfect square. And it is, because 6 times 6 is 36. So I'd have 2 under, 1 will come out. 7 times 7 is 49. 2 under, 1 will come out. So my answer is 6/7. All right, you go ahead and try this and come back to me when you're done. So put me on pause. Otherwise, you'd have square root of 64 over square root of 25. Plug it into your calculator, you get 8/5. What if we don't have perfect squares? So here's where we have to actually do a little bit of math work. I'm going to leave it under one radical right now because I can simplify. So remember when we have x to the 3rd over x, this one x in the bottom cancels with one of the x's in the top, leaving it instead of x to the 3rd x squared. And I know that 8 and 50 are both even numbers, so they're divisible by 2. So I'm going to simplify my fraction. So still under a big radical, 8 divided by 2 is 4. I have my x squared over 50 divided by 2, which is 25. And I don't have an x down there anymore. Now I've simplified it as much as I can because 4 and 25 don't have any common factors. So now I have square root of 4 x squared over square root of 25. And remember 4 is 2 times 2, x squared is x times x, over square root of 5 times 5. So I have some pairs, pair, a pair, and a pair. So 2x comes out, there's nothing left in the numerator, and a 5 comes out in the denominator, nothing left in, so I have 2x over 5. All right, so you try, simplify this one, put me on hold, and come back when you're done. And hopefully you realize 36 is divisible by 4, and you get 9. The bigger numbers in the numerator, so it ends up in the numerator. My a cancels out the numerator with one of the denominators, so I get 9 over a squared. And I break my radical apart, and then I simplify, and you should get 3 over a. All right, here's another example, same idea. This time I can't simplify first, so 25y to the 3rd over square root of z squared. 25 is 5 times 5 times y times y times y over square root of z times z. Look for my pairs. I have a pair of 5s, 1 comes out. Pair of y's, 1 comes out. I still have a y left in on top that I can't do anything with. And a pair of z's on the bottom and nothing left on the inside. So my simplified radical should be 5y square root of y over z. All right, so now we're going to talk about rationalizing the denominator. We said that there can't be any radicals in the denominator. You can have them in the numerator, but not in the denominator. So to get rid of them, remember we have just spent a few days knowing that if we have a pair of something under a radical, we can pull one out. So we need to somehow get a pair of 7s under a radical instead of just one 7. We're going to do that by multiplying by a specialized 1. Remember that 1 divided by 1 reduces to be 1. 10 divided by 10 reduces to be 1. X divided by x reduces to be 1. So I'm going to use the specialized 1 of square root of 7 divided by square root of 7. Again, that would just reduce to be the number 1. So I'm not changing the value of my expression because anything times 1 is just what we started with. But now I have square root of 3 times 7 in the top and square root of 7 times 7 in the bottom. I have my pair. 1 can come out in the bottom, so I just have a 7. In the top, I can't do anything with that 7 and the 3, so I just put them back together as the square root of 21 over 7. Not the square root of 7, but just 7. All right, so what am I going to do in this case? Again, I need a pair of 8 ends for 1 to come out, or I can simplify right away. So I can't simplify square root of 7, but 8 is square root of 4 times 2 times n, right? And square root of 4 I know is the number 2. So I'm going to get 7 over 2, square root of 2n's. So now what do I need to multiply by in order to get rid of the square root of 2n? I need another square root of 2n. If I do that across the top, I multiply a square root of 7 times 2n. And on the bottom, I have 2 square root of 2n times 2n. Well, I have some pairs. So on the top, I don't have anything, right? It's just going to go back together because I can't do anything to reduce it or simplify it in any way. But on the bottom, there's that 2. I have a pair of 2n's. So 1 comes out. And I would get square root of 14n over 2 times 2n, which is 4n. Again, I can't cancel because the square root of 14 is not an even number. That is not really n on the top. It's the square root of n, which is not the same as n. So that's as simplified as I can get it. All right, put me on pause and you guys try this one. And hopefully you multiply by square root of 3 over square root of 3 and got square root of 6 over 3. And go ahead and put me on pause and try this one. All right, there is all of my work, but you should see at the end you should get square root of 10m over 6m. And again, not simplifiable because square root of 10 is not an even number. All right, another example. Go ahead and try this one. Simplify what's under the radical first. All right, so hopefully you simplified the a's first. So you should get 11 square root of 49a squared over square root of 4. And when you simplify that, you should get 77a over 2. All right, that is it for today.